is first missing positive. So let me go to the VS Code. So for first missing positive, so what is the condition is that there is an array. You can see there is one array, and in that array we need to check the least missing positive. First missing positive means you can see here 1 2 3 4 5. 4 is not present, so 4 would be the answer. Here 1 2 3 4 5 is present, so 6 would be the answer. So this is the condition, but what we need to do, we need to solve. So what is the basic way of solving it? So we'll iterate through the loop, and we are for example, let's see how we are going to solve. Basically, what is the basic way of solving it? So first thing what I will do now, for I in array, if I not in range 1 comma length of array plus 1, return I. So this is the case, this is the basic solution how we are doing that. But it will, what I will say, it will fail some edge cases. Let's see, if the error length is too big and it will throw you time complexity. So let's discuss what is its time complexity of this program. For I in array, this is n time complexity. Again not in means again it is n time complexity, so the time complexity is n square. So for bigger cases it is the worst time complexity, and it will fail, and the interviewer will definitely reject your answer. So let's see how we can do it in more efficient way. So let's see. So this one you can see n equal to length of array. So I have declared a variable n which is storing the value of length of array, and I have started another variable flag which is initialized as false. Now what I will do, so as you know the first positive value is 1, so I will first check that whether 1 is present in the uh, loop, means 1 is present in the array or not. If it is present, then we will make the flag as true. So let's see. So let me run one for loop. So for I in range of n, if arr of I equal to 1, then the flag will be true, and this will be break the loop here. So this is one case. If 1 is not present, if 1 is present, then this will be the case. If 1 is not present, second case what we will do, if not flag, it will return 1. That means if 1 is not present, the answer should be 1. So for 1 the case has been taken care of. Let's go to the next thing. Let's think there are negative values, and there are values whose value is more than the length of array. Suppose there is let's see this array. You can see what is the length of this array, 1 2 3 4 5 6 and 7, but the values are more than 7, that is 100, 89, 90. So these values are more than 100. So these are two test cases. There may be some negative values as well. Here I haven't added any negative values. So what I will do in the next step, I am going to set all these values to 1. I am updating all these values to 1. So for this, for I in range of n, if arr of I less than equal to 0 or arr of I greater than n, then what I will do, I will make those elements as arr of I equal to 1. Now in the next step, what I will do, I will mark the occurrence of numbers and directly within the array. Let's see. I have again taken for I in range n, arr of I minus 1 percentile n plus equal to 1. So I am marking that the numbers are occurred in the array. Next step, I will check which index has value that is less than n. For example, if arr of I less than equal to n, then I need to return I plus 1. If arr has all the values from 1 to n, then this is the last edge case, it will return n plus 1, that is return n plus 1. So all the edge cases has been covered now. First edge case was like if 1 is missing, we don't need to go for all the array and it will return. Second case, we are checking the values that are out of range, that means whether it is negative or greater than the length of the array. Third case, I have marked the occurrence of the numbers in the same array. And fourth one, I am checking which index has value less than n. If that is less than n, then I am returning that error of index value plus 1. If all the values are present, I am returning length of array plus 1. So this is the solution. Let's see whether it is working for us or not. So first one, this is 1 2 3 589 90. So the output should be 4, because 1 2 3 is present but 4 is not present. So 4. In the second case, 1 2 3 4 5 is present but 6 is not present, so 6 is coming. So this has been working. So let's see what is its time complexity first. So time complexity is for I in range of n. This is n time complexity. If arr of I, this is 1 time complexity. So big O of n up to which the time complexity. Next come to this one. Again, this for I in range of n. Again same thing if. So this is again big O of n time complexity. Here same n time complexity, and here same n time complexity. So big O of n plus big O of n plus big O of n plus big O of n. So for big O of n, that means big O of n only. So this is the linear time complexity. I have fixed this problem in linear time complexity. Now what is the space complexity over here? Big O of 1, because we are taking one extra space. We are taking one extra space, that is n or arr of I. So this is our program. So this is about the second program.